Hello friends, welcome to my YouTube channel. Today we'll see the another example of periodic head flow for circular bank. So let's get started with the Ansys Fluent. Before that we will see the problem descriptions. So this is our geometry. It is a two-dimensional and we have a model half portion of the tube banks, and we will use the symmetricity for same. And here now you can see temperature of wall is given 550 Kelvin, then the bulk temperature is given 420 Kelvin, and the mass flow rate is given, that is 0.08. Overall dimension of the geometry is 50 by 200 mm. So let's start with the Ansys Fluent. I will call first geometry. I have created geometry in Creo. So we'll import geometry, right click and import. Just right click and open into the design modular. You can also open in a space claim. I am compatible with the design modular, so in design modular we will define the boundaries, definitions like inlet, outlet, then the wall, symmetricity. In previous example we had seen that we used the rectangle geometry of tube banks. Once it is open, click on generate, and now click on the Z. It is parallel to your screen. Now you can see we have the geometry. It is two-dimensional, and one part or body is here, periodic flow. If I select it, so just define here. First I will define, I will click here and see the name selection. Here I will give the name bottom tube, generate, then right click and say top tube, generate. Then this is our symmetric plane, so we'll give the name left side, left one symmetry. I will copy this, just enter. For the downside we will also select this edge and we will say left 2 symmetry. Here again select the top edge of right side and give it the name right 1 symmetry. I will copy this and bottom side, Control V, right 2, generate. For here you can see wall or input, not a issue. Sorry, inlet, generate, and this is our outlet. Okay, so we have defined. Now you can select, this is bottom tube, top tube, left symmetry 2, right symmetry 1, right symmetry 2, and inlet and outlet. So we have defined So just next step is save it and periodic flow circular. Next step is just close this design modular and open the mesh or attach the mesh to the geometry. Edit. It will take time. Once it is open, we'll define the mesh method. Okay, just click on Z. So here our name selections, and now we have to work on the mesh side. So we'll not go for the default mesh, we'll use the method meshing methods. Go just right click on mesh, insert and method, select the geometry. So in the method we have the quadrilateral dominant, then triangles and multi-zone quad tri. So first we will go with triangles. Generate mesh. Before that we need to change the physics preference mechanical to CFD. Regarding the sizing, we use the curvature and proximity. Relevance center should be fine, and the rest of the option will keep as it is. Now we'll check the mesh. If you found it is a chorus or medium, then we'll use the sizing for same. So still it is a chorus, so we'll use sizing option. Select the body and the element size. We'll define the element size. So as per our geometry, we have the maximum size 50 into 200 mm. So based on that we can define the element size. So here I will use 0.5 and just mesh it. It will take a little bit time because element size is very small compared to the geometry. Once it is done, we'll use the inclination. Now you can see we have very fine mesh, very fine. So along the cylinder we'll use the boundary layer, and to define the boundary layer just click here and inflation. Last time we used method scoping method by select the edge. Now this time we will use the boundary or name selections. So first select the body face and now go to the boundary scoping method, and in the geometry selection select name selection. So in the next tab you will find the all name selections. So just select bottom tube and top tube. So here you can see it's showing the multiple entities that we selected. Now you can see also here this red showing the two selected entities. Now go to the maximum layer. I will say 15 layers of growth rate 1.2. Just go and generate mesh. Because the temperature effect is around the cylinder, so that's why we go for the inflation to define the boundary layer, so we can capture the temperature field there very accurately. Now I will zoom it. Now you can see this is our boundary layer. We have given 15 layers of the increment of 1.2. So this is the hybrid mesh, we can say, because we have the triangle and we have the chord elements. Now we have done with the meshing. Just save it and then we'll go for the setup. Close the meshing environment, and now we'll attach the Fluent to mesh. And before go to setup, just update the mesh. So in this tutorial we'll see how to create a periodic zone, then define a specified periodic mass flow rate, then model periodic heat transfer with specified temperature at boundary conditions, and we'll use the pressure base solver pseudo transient with coupled solver, and we'll plot the temperature control, velocity control. So right click, double click on the setup. Go with double precision. Here you can see it is automatically detect the 2D. Just say okay. So first step is create a periodic zone, and for that we need a ID of particular zone. So first check in the console, you can see the information about the minimum face area, maximum volume, minimum volume, and the domain size in the meter. So we have in the x coordinate -1 0.01 to 0.01 in a meter, same in a y coordinate. Also you can check the report quality. Maximum aspect ratio is given, then orthogonal quality is given -0.4. Now you can change the unit for temperature and length. So we'll use length for mm and temperature in Kelvin. Yes. So we'll use pressure base solver, and it is a steady state. simulation, not a transient. In next step we'll define energy equation. Our flow is laminar, so we will not change anything here. We'll use the laminar model for same. And as I said that we have to define the periodic zone. So for that we need a inlet and outlet ID. So here now you can see if I select inlet, it automatically detects velocity inlet, and for outlet it is a pressure outlet, and in ID is given 12 for outlet and inlet is 11. So this ID we need. And after defining the periodic zone, now you can see the change in the type. So go to the console and select here mesh, enter, then modify dash zones, enter. Also type make periodic now it will ask you for the periodic zone. So for that we will use the inlet and ID was 11, and shadow zone will be our outlet. So here we'll give the value 12. So it asking about the rotational periodic. No, it is not, so we'll say no here. Create periodic zone, yes. Auto detect, yes. Now you can see zone 12 deleted, that was our outlet, and now it is defined as a shadow. And in the boundary condition you will see inlet, earlier it was showing velocity inlet, now it's showing the periodic. And now here you can also see this periodic condition is enabled, so just click on that and specify the mass flow. Mass flow rate is given 0.08 kg per second, and bulk upstream temperature is given, that is the 420 Kelvin. Say OK. So we have defined our boundary condition here, and before that defining wall temperature, wall boundary, need to define the fluid. So we are using the water, so just go to the Fluent database and select the water. Water liquid, just copy and close it. Now we have the property here, just create and close. And next step is very important, to define the sail zone. So here you can see we have the periodic flow, and just edit. Now you can see here at the moment it's showing the air, we have to change with the water liquid. So our sail zone is defined by water. Now next step is we will define the rest of the boundary condition for the top tube and bottom tube. So just click on the bottom tube and go to the periodic, sorry, not go to the edit, and define the temperature. So for that we need 550 Kelvin is given. Okay, same for the top tube, double click on that and define the temperature in thermal tab. Yeah, now we have defined our boundary conditions. Now next step is we have to select the methods, solution method. In that as we discussed, we'll go with the coupled and the shadow transient and keep the rest of the option as it is. Go to the control. At the moment we have given energy equation 0.75 or 1. If we found any error regarding the AGM detection, in that condition we will reduce the this value. So first we will go with the 1 and we will see what happens. Then in the monitor we will define residuals. For the continuity equation it is 10 raised to 1, and for the energy equation it is always 6. Okay, then, and in initialization, first we will go with the hybrid initializations. In the hybrid initializations, it initialize the flow field based on the inlet and outlet boundary conditions. So that's why we will use hybrid initialization, and you have to then patch with our bulk temperature. So just say patch. Here we have the temperature, and this is our patch zone, and you can see, you can define here again our bulk temperature, that is 420 Kelvin, and say patch, and close it. So we have done with the initialization. Now go with the run, and here first just write autosave and define the iterations save data at every 3 iterations. Now go with the run. Here we will define the 350 iterations, and we'll calculate. First we will check that we will have any error. Now you can see a message showing its iteration is writing at every 3 iterations. So we don't have any error, so it will take time. So I will come back once the solution is complete. Hello friends, welcome back to now you can see calculation completed, and as per our criteria, residual criteria, continuity equation goes below 10 raised to minus 3, and the energy equation 10 raised to minus 6. So based on that we can say our solution is converged. Also you can see the flux balancing, and based on that we can confirm that solution is converged. Now we will see the post processing. We'll go with the graphics and we'll see some contours. Or first we'll go with the temperature control, or first we'll go with the pressure. Select fill and pressure, static pressure, and just say display. Now we'll go with the smooth, and also you can open. Now you can open the symmetric planes, go to the view and select all these symmetric planes and apply. Now you can see we have the complete tube bank, and now you can see here we have the maximum pressure, and around top and bottom of the tube bank we have low pressure. Again we will create a new contour for the temperature. Take the temperature and static temperature, say display, Now here you can see uh, we have the maximum temperature around the tube bank, and this is because heat transfer from the tube, and at the temperature increases in the fluid due to the heat transfer from the tubes, and the hotter fluid is confined to the near wall end and wake region, while a narrow stream, you can see this stream of cool water is convected through the tube bank. And this is the periodic, so that's why we have defined a partial geometry of the tube banks. Also we'll see the velocity contour, and select the velocity and velocity contour, say display. Here you can also see the maximum velocity around top and bottom of the tube bank, and that is almost 4.4 e raised to minus 0.03 based on our mass flow rate. Again you can also see the vector, so we'll see the velocity vector. Just increase the scale, go with the 5, 10. Now you can see so in this tutorial we have seen the periodic flow and heat transfer in a staggered tube bank, where model in Ansys Fluent. The model was set up as assuming a known mass flow through the tube bank and constant wall temperature. Due to the periodic nature of the flow and symmetry of the geometry, only a small piece of the full geometry was modeled. The tube bank configuration lent itself to use of a hybrid mesh that we had seen in the meshing, that we have quadrilateral cell around the tubes and triangular elsewhere. So you can also check other possibility with changing the value of Reynolds numbers, flow rate, and the geometry dimension. So if you like this tutorial, please press the button, and also subscribe my channel. In next tutorial we will see different topics. So in the description I have given my previous video links, so please go through that. Thank you very much.